let me show you how to make a data stream in your Satori node. So you've downloaded Satori, you have it running, it's up and going. You can go to the UI and see this list of data streams. Now, I don't have any here because I haven't set any up. This is manual work. You have to set each one of these up manually. So, you can do that with this form right down here. And it's pretty easy, but it's a little nuanced. So we'll go through it step by step. First of all, you're going to provide a name and you're going to provide a target, a cadence, and a URL. And that's the most basic stuff you need. Providing these others is always a good idea. Don't worry about the history portion. We can do that after the data stream is created. So just ignore this part. And probably ignore this part. We'll go into it, but, oops, I don't want that. But most likely you won't have to do anything with this. Okay. So what data stream do we want? So I have this URL over here. It's Coinbase, exchange rates, USD. So what we're going to grab is the USD price of ADA right there. We can look at this. It's a JSON object. It's got a data key with another JSON object inside of it, which has a rates key with another JSON object, a big one, which has a bunch of keys, and the one we want is ADA. So what we're going to do is we're going to tell our neuron, go to this URL, go into the object that you grab, that you receive, and find the ADA portion, item, and grab that data. Just this one metric. Just grab that. Okay? So we're going to do that. So we're going to grab this. Okay. So let's go back. We'll take the URL. Let's copy that. We're going to need that. We're going to put it right here. Notice there's a URL and there's a URI. The URL is public data. This is going to be sent up. Anybody can see this. It's, the network can inspect where you're getting the data, that kind of thing. But the URI is private. This is only saved on your machine, as well as the headers and the payload, because they might have secret information. You might have to provide a key to get the data that you're getting, right? So if you have a secret key that you need to put in the URL, you can do it here. If your headers need a secret key, they're private. So, or if your payload has a secret, it's private. So this stuff does not get sent up to the network. It stays local on your machine, these three. But the URI is public. Pretty much everything else is public. So, okay. So we're going to put in a URL, and we don't have a secret key, so we don't need to mess around with anything else. Just the URL is fine for us. This is a simple example. And remember, we looked at this data, and what we know is the way to traverse the JSON object that you're going to get back in order to get the data. And so we know that. We know that it's data.rates.ada. And so that's what we're going to put in as the target. Okay, data.rates.ada, like that, just like that. And the name is just going to be any kind of descriptive name of what we're getting. So we're going to call this one Coinbase ADA USD. I guess that's pretty good. Yeah, let's just call it that. Well, okay, let's do 10 minutes. Because we're going to tell our neuron to go out and grab this data every 10 minutes. Okay. That's fine, I guess. There's no standard for how to name a string yet, so whatever. the data type that we're getting and relaying onto the network, that little metric, that is a price, and prices are floats. Float. And we're going to tag this data stream and like kind of so that people can search it perhaps. So it's Coinbase is where we're getting the data from, and it's ADA. That should be fine, I guess. The more descriptive, the more tags, the better. You know, whatever. Go wild. The description, we're going to say the price of ADA in USD every 10 minutes from Coinbase. And headers, of course, we don't have to deal with that. So this is usually the only stuff you'll fill out. Plus one more thing, I suppose. So remember, we had to kind of be careful about what we put in as the target. If we're getting, you can put anything in as the target, but we put in this very specific, you know, JSON traversal path for a reason. And that is because when your Satori Neuron goes out and gets the data, it doesn't know what to grab, like which one of these, you know, and how do I go get it? You know, what's the path in the JSON object to go get it? And so if it's a JSON object, which will be most cases, you can put in the path, and then you can tell your Satori Neuron how to get it with this hook. This hook is the actual thing that goes and gets the data. This little function, it's a Python function. Sorry. So you can put anything in here. If what you're grabbing is not JSON, it's something else, you can put, you know, any kind of logic to go get the correct data from the response you want. So, but the default logic looks at what you put in at the target and says, I'm going to assume that they're grabbing a JSON object and that the target describes how to grab the data. So it will then say, okay, well, I got my response, which is this entire, you know, data, and I'm going to look at data, and then I'm going to look at rates inside that, then I'm going to look at ADA inside that. I'm going to turn that into a float, and then I'm going to return it. Now that is what is going to get broadcasted out to the Satori network for everybody else to predict. So I just clicked in on this this text field, and it automatically generated this function, and then I'm going to hit save. Okay. Now what it's doing right now is it's actually testing what I put in, making sure it works. So it's going to the URL, it's running this function, it's validating the data first, and it's actually grabbing the data and making sure that it's valid and that it works. And then it's going to post it up to the network so that it's saved. And here we have now our data streams. Oh, here's our little, you know, the stream has been saved, and we did a test and we got a result, and here it was. And so it now shows up in our list of data streams. These are the data streams we're relaying onto the network, as opposed to these ones, which is the data streams that we're predicting. And with these, we have a few actions we can perform. You can't really do anything with the data streams you're predicting because your computer's just going to be predicting them all the time automatically. But with the data streams that you're relaying, you can remove it, you can edit it, you can download its history. You know, every time that it's gone out and got the data, you can inspect that. You can also upload additional history, and you can remove history. So for instance, let's say I just created this, this stream, and I just have a whole bunch of history that I want to put in right now. I can remove what's there, which would just be that one call, and I can add in the new one, the real data. So let's do that. Let's do that as an example. Let's just add some additional history. First, we'll download it and just take a look. Yeah, this is it, right? Yes. Okay. So where did you go? Where did you go? I'm sorry, there we go. Oh. Okay, it's off the screen. Sorry, guys. Just a minute. What? Oh my God, open OS. Okay, we'll try that again. Yes, this is what, well, okay, let's just look at it. Let's look at it here. Okay, so we have an index, and that is the time, the timestamp of when it grabbed the data. And it has a value, which is, the value we saw, basically. And let's try to get it to open. And it is like off the screen somewhere. Which is, oh, there we go. I got it. Sorry, everybody. Sorry for making you wait. Okay. Okay, so there it is. Right. Okay, so no problem. Let's pretend that we have some other data. So let's actually make some other data. Let's pretend we have a history. And we should upload a history with every data stream, because neurons are going to be using these data streams to predict, so they need a history to kind of learn something from in order to predict. So if, a lot of the manual work is actually grabbing the history and compiling the history into an index and a value for like 10 years or however long we can get, and then uploading it this way. So let's just fake it, and we'll pretend that we have, a little history here. So it's every 10 minutes, so let's make our history match that. We've got 43, let's do 33, let's do 23, and that's 8.4. Let's just change this to be 8.3 and 8.2. Okay, so now we have our spoofed, let's change this to be 8.4. We have our spoofed history. Okay, these, really it's going to be, notice this is the same time as our real data that it went out and grabbed. So just notice that. Okay, so let's save this as history. Save as history. And then we'll close that, and we'll add it to our data. So which one is it? History. Okay, so now it's there. We can now download the history again. Open it. And look at that. It replaced the one that was already there with the one we supplied because it matched the time exactly. So it got rid of, everything after that, 84, because it matched exactly. Okay, so I just wanted to make you aware. If it didn't match exactly, it would have that number here. Okay, it would have appended or prepended these two, and whatever we had. I guess it would have prepended all three of these probably. Okay, well, that's a data stream. When you create a data stream, you have created an oracle. You've turned your Satori node into an oracle. It's an oracle for this data. And now other nodes can subscribe to that data from you and predict it. And so they'll automatically make predictions on your data stream. Okay, that's the tutorial for how to set one up. And I didn't go into grabbing the data because that's more nuanced. Grabbing the history, compiling the history, adding the history to the data stream. That's important to do, but you're just gonna have to do it. Sorry. I can't automate that, right? Okay. So I thought maybe I would just take a minute to talk about what this is doing. Like, why are we relaying these data streams? Obviously, so that other neurons can predict it, but what does that get you? I mean, this was a lot of manual work, setting up the data stream, getting the history, appending the history to the data, and then you're done, right? And then if this API ever changes, which APIs are not supposed to change, they're supposed to be versioned, but if it does, you have to come back in here and make a new data stream, edit your data stream, do something, right? You got to do something. So all of that manual labor, what's the point? Like, what am I getting for that? Well, if you go here to the Satori website, you can see the tokenomics page, mining. And what Satori does is community-led mining. And that means there are certain activities that you can do to earn token. Various activities. It's not just one thing. Like blockchain has hash mining. It's just that one algorithm, and that's all you can do. And then whatever. So this community-led mining allows us to make a list of things that anybody can do to earn tokens. Of course, the whole point of the network is to predict the future. So competitively accurate predictions are 50% of the rewards. They go to the neurons that are making good predictions. Okay. But 20% of the rewards are going to those that create these data streams of raw data. And so the predictions are automated work. It's automated. Your computer's going to do it. You don't have to do it. You just download the node and run it, and you're done. But if you wanted to do manual work that we just did, you can earn some token because the network needs raw data to predict. So if you make a data stream and you relay this data stream onto the network, and the network sanctions it, that happens by vote. The network sanctions it as a trusted data source. You have a trusted oracle. Then you start earning these rewards. And then on a separate note, managing the infrastructure that keeps Satori up and running is 10% of the reward, and there's a dev fund for further development, 20%. Now, because this is community-led mining, these rewards, they're variable. They are voted on by the community, and they can change. And it's literally the token holders that decide what this minting manifest looks like. Okay. And that's to make it dynamic. Because in the beginning, maybe the relay sanctioned rewards should be really high. Maybe it should be 50%, 90%. Who knows? Because the network needs data in the beginning. Once the network is matured, it's going to be focused a lot more on prediction than obtaining oracles and data streams. So by having the community be in charge of these numbers on a continual basis, that makes these numbers dynamic. That makes the network responsive to the environment in which it exists. Okay, so that's the whole point. Okay, sorry. We're not going to go into this minting manifest anymore, but I will mention one other thing. So the data streams that get sanctioned, the reason that it's important for only specific data streams to be sanctioned as, prediction eligible, is that we want a way to be able to trust which data streams are valuable. So the network can look at these data streams, inspect them, and then sanction the ones that have long histories. Like, let's say I made this and somebody else did the exact same thing, but they put on, 15 years of data or however long ADA has been around. And the network will look at these two data streams and say, well, we're going to sanction the one with all the data, all the history, not the one that has really short history. So there's a competition between these to be the best oracle. Okay. And the other reason it's really important for the token holders to be in charge of which data streams are sanctioned is because the token holders need to be in control of what the Satori network predicts. Or in other words, the token holders need to be in control of where Satori's attention goes. Should it pay attention to prices, economic data? Should it pay attention to environment? Should it pay attention to government statistics and demographics? What should it pay attention to? What's important? That is determined by the token holders. It's not determined by the Satori Foundation. It's not determined by the miners. It is the token holders that manage that. And it should be. It should be the token holders. That's the point of the token, is to give you power over the attention of the Satori network. And attention is everything. So that is done through the voting. Now, we don't have this implemented yet because we're just entering beta, but we will. We will soon. I guess that's all ancillary to the tutorial of how to set up a data stream, but I think it's important to kind of understand like why and what's the importance of these data streams. It's to direct the attention of the network on predicting the future. There's a lot of stuff you could predict, like what kind of future do we care about caring about? Well, okay. Sanctioned data streams is what we're going to be predicting. And what gets sanctioned? Well, you got to own some Satori token, and then you can vote on what gets sanctioned. What's important to know what it's going to be in the future. What matters. All right. So, thank you. I hope this was helpful or beneficial. Again, just a quick recap. Ignore this history portion. Fill out the name, fill out the cadence, fill out the URL, fill out the data type tags and description are really helpful and good. This offset I didn't discuss. Offset is cadence, so you don't really have to deal with it. I mean, if you don't want to. But what it means is this cadence is going to be automatically interpreted as in what's it called? UTX time? I'm sorry, just the most basic time zone. And so the offset is saying, well, how many hours am I away from the most basic time zone? I know, it's annoying. So really, it's not a big deal. But that describes a modification on cadence. And then there's the target, which you can put anything in here, but it's best if you're dealing with a JSON object to put the JSON path to the actual value that you want. And then the name can be anything descriptive of what you're producing. After you fill all that out, just click into Hook. And yeah, that's old. Just click into Hook and it will automatically use the target to generate a function that grabs the appropriate data, or if your data is not JSON, You can write your own function. You got to kind of be a programmer or know how to script in order to do that. And then you hit save. And then you're done. Oh, you're not done. Sorry. Hopefully you have already got the history of the data, and you'll append it using this button right here. You'll prepend it to the data using this button right here. And then you're done. So thank you for listening. That's how you set up your neuron as a Satori Oracle, relaying this raw data onto the network. Thanks.